Very good afternoon, class. I hope you all are doing good. Now let's start with today's lecture. In yesterday's lecture, we were doing presentation layer, responsibilities and functions of presentation layer. We discussed the first responsibility, translation. We were doing the second, encryption, decryption. We discussed the basic concept of encryption, decryption. Then we started with the various types of encryption, decryption, conventional method we were doing. In conventional method, right now we were doing character level. In character level, we discussed monoalphabetic, we were discussing polyalphabetic, and we discussed only one method to do polyalphabetic, that is to find the position of the character in the text and use that as a value of key. If you can see here on the screen, we discussed this dear friend example, and we discussed this disadvantage that could be followed. So today now we will be starting with the second method of the polyalphabetic encryption, which is called as beginner cipher. What we do basically here is we make a 26 cross 26 two-dimensional table. Why I have taken 26 as a number? Because total characters in an A to Z ABCD is 26 characters. So we have taken 26 rows, 26 columns. What we basically do is, if you have a word dear to make it into ciphertext, you see the position of the character. D is on the first position, so that makes your row number. Row number is given by the position of the character, and then column number is given as, here you can see position of character in alphabet, means A as 1, B as 2, C as 3, D as 4, so on, Z as 26. So D as 4 we'll take in row number 1 and column number 4. The number on that crisscross table gives you the character which will replace D. In this algorithm, you replaces the character with the character in the table that corresponds to that column and row number. In this way, you do replacement of a character which is polyalphabetic, that each time it can be different, and in this method it is very difficult to make out on the basis of occurrence, because every time it keeps on changing randomly, right? This was our substitution method. Today we will discuss our second method, that is transpositional method. What is transpositional? As the name tells you, transposition. You are changing the position of the character in the plain text. Actually, the plain text remains the same. You are not changing character in the plain text. In ciphertext also, they are the same characters. You are only changing the position of the characters in the plain text. How we do it is, you make your plain text, organize that in a 2D table form, columns and rows, and you interchange them according to the key. What I mean here is, it will be clear with the help of this example. The sender wants to send a plain text, so you will do some transposition here. It will get converted into ciphertext. Again, reverse transposition is done. This is decryption, and it will be converted into plain text. This is our basic encryption method. Let's see at example. You want to send a plain text, a good friend is better than a treasure, right? You are converting it in a 2D table form. Here I have taken that I am taking 11 columns. So what I am doing is, A is written under first column, then second is remained at space, then good is written in each character under one column, then set space, then good, friend is a better than a treasure. In this way, you have organized it into a 2D table. Now, coming on encryption process, how you will transpose this plain text. Here is a key. Encryption and decryption keys are same. Why they are same? Because you are doing conventional method. In conventional method, encryption, decryption keys are same and secret. What we do here is, we have written the numbers from 1 to 11 and the position on which it will be transposed. That means first position will be, on first position you will write the 6th column, on second position you will write the 9th column, on third position you will write the 3rd column, so on. Look, you will look here how this is our first column, number here is 6. So this is the 6th column, DDRA. you will write DDRA here on the first position. Second bit you have to write ninth. Ninth is, here you can see OSTER. So that is written here. Third is third. GITR to GITR will be written as, GITT will be written as same. In decryption, what you will do is, iska reverse you can do again. On the first, you will write the sixth. That is AFBA. On the second, you will write 9. RE. So RE will be written here. In this way, you will again retrieve back the plain text. This is transpositional method. It is not very secure because character frequency can be preserved as it was done in monoalphabetic. Right? These were our conventional method of character level. Today, now we will discuss bit level encryption. That means bit by bit, not character. If C is a character, ASCII of it is a 7-bit or 8-bit, you are treating each and every bit individually. What we do basically in bit level algorithm is that your data to be encrypted can be anything, text, any graphics, audio, video. Basically all these are changed into bits, and you organize these bits in the form of blocks. Blocks of bits are made. Then you can encrypt them using any technique, encoding, decoding, permutation, substitution, XOR, rotation, and so on. There are so many methods with which you can do bit level encryption. Some few of the methods we'll discuss here. Starting with the first method, that is encoding, decoding. I hope you all have studied earlier in DE also encoder, decoder. What is encoder, decoder? Coming to decoder, decoder changes n bits of input into an output of 2 to the power n. What I mean here, in this example, I have taken n as 2. If 2 input lines, 2 to the power 2 is 4, 4 output lines. So this is a 2 cross 4 decoder. 2 input lines, 4 output lines. If the inputs are 0, 0, output will be 0, 0, 1. That means one of the output line is active at this time. If 0, 1, 0, 0, 1, 0 will be the output. If 1, 0, 0, 1, 0, 0. So on, you have made it a table for decoding. Reverse of this is encoder, 4 cross 2 encoder. If input is 4, then 2 to the power n is the input, n are the output line. This is how encoding, decoding comes. Suppose the plain text is 0, 0, so it will be encrypted as 0001. If the plain text is 01, it will be encrypted as 0010. So on, you can do encryption and then decryption using this reverse process bit by bit. Clear? You will break them in the blocks of 2 if you are using a 2 cross 4 decoder. Coming on the next method, that is permutation. What is permutation? Permutation is basically transposition at bit level. You are changing the positions. You are setting some permutations and combinations to change the position. There are various types of permutation. 3 types what we will be discussing here are straight permutation, that number of bits in the input and the output are preserved. It's same है. अब 4 bit का input दिया, 4 bit का output मिला. No change in the number of bits. Only the positions are changed. Next type of permutation is compressed permutation. What is compressed permutation? That number of bits are reduced. It is compressed. If you have given, for example, 4 bit, the output is 3 bit or 2 bit. That the number of output bits gets reduced as compared to the number of input bits. Expanded permutation. Expanded means you are expanding the number of bits. They are increased. From 4, you will change it to 5, 6 or 7. That you are changing the number of bits. Let us have a look how we are doing it. These permutations are known, you make basically a circuit. Looking here at the diagram, what permutation is doing is you design a hardware circuit with some internal wirings connecting the inputs to the outputs. The operations can be easily performed. You give some bits as an input to your circuit, hardware circuit, and you receive the output. These units made are known as P boxes, that is permutation boxes. We have discussed 3 types of permutation: straight, compressed, and expanded. Here are the diagram with the example. Straight means number of input remains same as number of outputs. If there are 8 bits, 8s are at the input. What we are doing is you are just changing the position. Like first circuit pin is connected to this 5th, this second is connected to some fourth. Randomly you have made some connections, means you will give your plain text as the input, and after this permutation change in position you will receive the ciphertext. At the decryption side, this will be done as reverse. This will be the input and this will be the output, right? In the compress, what you are doing is some of the input lines are more than one or two are connected with the output line. That means you are reducing number of bits. So, opposite is done in expanded form. Like this one pen is connected to 2. This one gets changed to 1 here and 1 here. You are increasing the number of bits in the ciphertext. If your, for example, 8 bits are plain text, but more than 8 bits are sent as the ciphertext, then the ciphertext will be decrypted into plain text. These are your P boxes. Let us discuss another method, that is your substitution method. What is substitution is that n bits are replaced by another n bits, right? Same, the number of bits are not changed, but this is done with the help of using the combination of P boxes, encoders and decoders. That the two methods we have discussed earlier. Suppose we have an input of 2 and the output of 2. This is your S box, substitution box. What you are doing is this is a 2-bit S box. That 2-bit of input is given and the 2-bit of output is received. What you are doing is a 2x4 decoder is used. So 2 bits gets converted into 4-bit output. You are using a P box here, that is a permutation box. These 4 bits are randomly done permutation. Now encoder, that 4 will get converted into 2 because in N box number of bits don't change in the input and the output. Those 4 bits get converted into 2 bits back. So this is a combination of encoder, decoder and P box. For example, 0, 0 is replaced by 0, 1. If you do this example mathematically, you can practice on paper, you will find this as a result, that 00 if it's the plain text, the ciphertext will be 0, 1. If 0, 1, it will be 0, 0. Like the reverse process keeps on going. This is your substitution. Let us discuss the last method today, product. What is product? Product, P boxes and X boxes can be combined and that is called as a product. You can basically, this is in several stages it is done. Here in the diagram it is very much clear. If 8-bit of plain text, 8-bit of ciphertext, this is a product box. What you are doing is, first you have placed the P box, that is a permutation box. These 8 bits will be permutated. Then you are dividing it into 2 bits of blocks. S blocks, 4 S blocks are placed. Some substitution is done. Then again P box, then again series of S box, then P box. You can change any number, several stages of P and S boxes can be placed. It can be even done in the 2 or 3. This is your product, right? So we were discussing bit level encryption methods, right? Let's discuss the last method, XOR. We'll be over with bit level and we'll discuss this DES in the next lecture. What is XOR and DE? We have already discussed the XOR function. If 2 bits are same, the XOR of the bit is 0. If 2 bits are different, the XOR is 1. Same we are doing here is what is done at the sender side. This is your plain text. And this is a key which is being shared at the both sender and the receiver. You do the XOR of the key with the plain text. 1, 1, the XOR is 0. 1, 0, the XOR is 1. 1, 0, the XOR is 1. So on. This will be a 8-bit ciphertext received by XOR of the plain text and the key. Receiver also have the same key. It has now this ciphertext. You will again do the XOR of the key and the same plain text will be received at the receiver end. So class, today we discussed the bit level encryption methods. So we are over with the character level and bit level, the two basic categorization of conventional method. In tomorrow's class, we will be discussing next method of encryption, that is DES. Thank you.